To create an assembly, select on create assembly and give your assembly a name. I'll go for undivided crown road and keep all the defaults. Click on OK and look for a suitable place on your screen and drop it. This is your assembly. Then the next thing to do is to attach sub-assemblies to this assembly. To do that, it selects this icon, tool palette, and this should come up on your screen. I'll add a lane by the name lane super elevation AOR. Properties should pop up on your screen automatically. However, I have my properties docked on my screen. That's why it didn't come up. So I would have to navigate to it to activate it. So I have the side to be right, meaning that when I'm attaching the sub-assembly to this assembly, it will be to the right side of the assembly. And I have width, which I would go for 3.65 meters, default slope of -2%. Pave depth, I would keep this default and increase the sub-base, the base and sub-base depth. For potential pivot, I'd go for no, since we're not using super elevation for this assignment. Okay, then I'll click on the right side of the assembly. So I have my road here. Now this here is the pave 1, pave 2, base material, and the sub base. Okay, when this is done, I would like to attach a drain to this road section and also give it a daylight. To do that, I'll come back to the tool palette, go to daylight and select daylight basin. Come back to properties here. This information represented here, you may need more information about them, more descriptive information about them. To get those information, you could drop the sub-assembly and select the sub-assembly, click on sub-assembly properties, click on parameters tab, and click on sub-assembly help. It will give you more information about it. Now to change some information to change the parameters of this sub-assembly, come back to properties. I'll change the for slope to 1.1, which doesn't really matter because I wouldn't be using for slope width. So for the for slope width, I would go for 0.0001. Why I have this is that Civil 3D doesn't really like a zero figure. So to manipulate your way around, you'd use a very minute figure. That's the more reason why I used 0.00001. And for the basin depth, I would go for 0.5 meters, basin slope 1:1, basin width 0.5 is okay, depending on the hydrology and the catchment and the section that you're designing. This now it's a drain, more of a channel. The berm width, I would like to take it away, so I'll use something really small too. Then my chord slope 1:1, fill slope 1:1. Rounded option, you get more information about it within the sub-assembly properties. Now I have this on my screen. The cut and the fill slope is represented here 1:1, even though these figures are really big. To reduce this to fit in perfectly into the drawing, you have to reduce the scale of the drawing to maybe 1:250. It would fit in better. Okay, I could mirror whatever I have here to the other side of the road instead of bringing or coming up with each of the sub-assemblies. So I'll select everything I would like to mirror, right click and go for mirror, or rather you could use mirror within the ribbon. Then it says select marker point within subassembly for the mirrored subassembly. To do that, I'll click on this assembly itself to mirror the whole of these elements using this um, as the axis. Okay. When this is done, the next thing to do is to model the corridor. Now for that, you could select the assembly. The contextual ribbon for this assembly comes up. Everything you could do with the assembly would be represented on this ribbon. Now I'd like to create a corridor using this subassembly. Now for the corridor, I'd like to use give it a name CESE layout, and I'll keep this default. The baseline type is alignment and profile, and for alignment I would use this, which is actually the alignment I'm trying to model this assembly on. The same thing for the profile. Then within subassembly, or choose, it's quite possible that within this project we've got a lot of assemblies. Now you select the one that you want to superimpose on the alignment. I'd go for undivided ground road and target surface existing ground level. Uncheck this and click on OK. When you click on OK, you see that your road is modeled on this alignment. Okay. Now the next thing to do is to play around with the corridor a little bit. When you select the corridor, you would notice this triangular grip. This triangular grip would give you the opportunity to start your corridor or move the beginning of the corridor to whichever station of choice. I could drop it here, and the same thing is applicable to the other side of the road. I could bring this back a little bit and take it back to where it was. Okay, when that is done, click on the corridor and go to corridor properties. We would like to create corridor surface and corridor boundary. For corridor surface, go to the surfaces tab, click on create a corridor surface. There are two data types here, feature lines and links. Go for links because the surface we'd like to create is defined by link. And specify code, I'll keep it as top. Then click on this plus sign. The top is what is defining the link, and the link is what defines the corridor surface. I'll rename this one for better description, CESE layout corridor surface. Okay, when that is done, I'll click on OK. The software would ask me if I would like to rebuild the corridor. I'll go for rebuild corridor, and I have this on my screen. Sometimes the corridor is not within the boundary of, or the surface is not within the boundary of the corridor. Now to correct that mistake, here we don't have such. To correct that error, you click on the corridor once again, you go to corridor properties and down to boundaries tab. You right click on this corridor surface we created recently and select corridor extends as outer boundary. You could rename this one to something more suitable like corridor boundary, and OK to build corridor. Now this is what we have here. This is a short description of how to create a corridor, starting with an assembly, and from the corridor you could take it as far as creating a corridor surface and also having a boundary to the corridor surface. One other thing we could do with our corridor is to split it. To do that, go back to corridor properties and back to parameters. Okay, now here, this is the first baseline, and this is the region attached to the baseline. The baseline is defined by the horizontal baseline and the vertical baseline, which is our alignment and our profile, which starts at this station and ends at this station. Now, within this baseline, there's a region. However, this region is starting from the beginning of this baseline to the end of the baseline. If you like that the region would start from somewhere within the alignment, not necessarily at the beginning, you only have to type in where you want to start here and where you want to end here. It's quite possible that you'd want another region within the same road of different cross section. To do that, all you have to do is to right click on your baseline and click on add region. You give the region a name and you select a suitable assembly to it. Currently in this project, we only have one assembly. You click on OK. Now note something, that the first region is starting from the beginning of the road to the end of the road, and the next region could not fit in because the first region has taken the whole of the length. Now, to effect or to show how this works, I would have to reduce this to something smaller than the whole stretch of the road. So this is from 0, 0 to 150, and let's this start from 0 plus 150, which is actually where the first region ends. And I'll click on OK. Accept this, rebuild the corridor, and note that we now have two sections. We now have two cross sections. Take this back a little bit, and this is what we have. Okay. After this stage, what we could do again is to explain a little bit of frequencies. For that, you go back to corridor properties. Let's clear out this region, remove region, and take this back to the end of the state, or the end station, the end of the alignment, 0 plus 269.70. Okay, what I could do here is to manually select the end of the region. For that, I would select this icon towards the end of this field. When you click on this icon, you could navigate to the corridor and click on the end of your alignment. So it is automatically snapped to the end of the alignment. For these frequencies, what it does basically is that it gives ranges or intervals at which the corridor is modeled. Now here we've got 20 meters. It means that for every 20 meters, the assembly would be placed on the alignment, and those 2 points between the subsequent assembly and the current one that is being placed, the links will be connected. Okay, now to effect changes to this frequency, you'd click on these three dots and give the frequencies at which you want the changes to be made, or you want the modeling to be made. Along tangents would use 25 meters, and along curves would use 25 meters. Along spirals we use 25 meters, even though we don't have that in this project. And you could toggle this off if you don't want it to model at horizontal geometry points and critical super elevation critical points. Okay, within the vertical baseline, it could also be at 25 meters, and if you don't want it to be modeled at every vertical geometry point, you could toggle this off, and also for high and low points. When you're done, you click on OK, and you have to rebuild the corridor once again. So now here we've got from the beginning of the road to 25 meters chainage, we've got one frequency, and from here again we've got another frequency. This is meant to be 50, and this is actually a PC point of curve, so it has been modeled at this point of curve because it is a horizontal geometry point, and that's how it works. Thank you.